Hi students, welcome to the screencast on the guess and test strategy. The guess and test strategy is a strategy that's not extremely sophisticated, but it's one that always works in a pinch. So what we're going to do in this screencast is first just talk through the notes that are already typed at the top of the page, and then work a problem together. If you haven't printed out the note sheet, it would be a great idea because I think it really helps to work along, especially when I tell you to pause and try something on your own. So the guess and test strategy is really most appropriate when you can't figure out anything better to do. I always say guess and test can always work. It just might take a lot of perseverance to get through it. I also think guess and test is great if you're not even sure what a problem is asking. So when I work with students in a classroom and they're saying, I'm not sure I understand the problem, the first thing I do is just kind of give a guess and plug numbers in and work through the problem so that they get a good understanding of even what's going on. So the guess and test is really helpful, first of all, because if all else fails, you go back to it and you put in, the brute force to get to an answer. The other great thing about guess and test is that sometimes after you start using it, you figure out, wow, I think I could do it this way and get to the answer a lot faster. So often it's just a starting point, and then you end up actually using a more sophisticated strategy. There's actually 3 types of guess and test, and the first one is random. So that means you just essentially take stabs in the dark, see if it's the right answer. If not, take another stab in the dark, see if it's the right answer, and you keep going until you hit on the right answer. A little bit more sophisticated than that is systematic guess and test. And when you do that, you're still just almost making random guesses, but at least you're keeping track of the guesses that you use, and you're also trying to do it systematically so that you'll know when you have tried everything. So you're just trying to keep a good track of what's going on. And the final guess and test, and this is the one that often leads to being able to use a more sophisticated strategy, is called inferential guess and test. So inferential guess and test means that you are making some assumptions. You're not just taking stabs in the dark. You're saying, I know this and this and this, and because I know those things, this is the first guess that I'm going to use. And then sometimes as you go through, you learn some more things, and it keeps refining your guesses more and more. So this little problem down here is called a cryptorhythm. So each letter stands for 1 digit. And sometimes people are a little bit confused on what it means by digit. But digit is just a single numeral. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there are 4 letters here, and each letter has to be a different digit. So we'll start out here and just kind of do a random guess and test. So let's say that I just, at random, say, let's let A be 4. Let's let B be 3. Let's let C be 2. And what the heck, let's let D be equal to 7. So when I try the problem here, and at this point, you can watch a little bit more, but then I want you to pause and give this a try. So this means I'm going to take 4, 3, 2, 7, and I'm going to multiply that by 4, and then I'm going to check to see if I got the right answer here the first time. All right, so 7 times 4 is 28, so I put down my 8, and I carry my 2. 2 times 4 is 8, plus 2 more is 10. So I put a 0, carry my 1. 3 times 4 is 12, so that's 13. 4 times 4 is 16, plus 1 is 17. All right, so I can look at this really quickly and know there is no way this is the right answer, because my correct answer is supposed to be DCBA, which is only 4 digits long, and I ended up with 5 digits. So at this point, what you should do is pause the recording and try a couple more guesses on your own And as you're trying the guesses, see if you can make any inferences and use those inferences to try to get to an answer. If you're motivated, and hopefully you are, maybe you'll work at it until you do find the correct answer and then check back. Otherwise, at least give it a couple tries. See if you can make at least one inference. Can you figure out at least one letter based just on using some reasoning skills? Okay, so we're going to continue on here, and we're just going to talk about some inferences that we can make to try to make our guess and test go more quickly here. So hopefully you've already made some inferences, and maybe they'll be the same ones that I'm going to make here. So the first thing that I made an inference about, it comes from my first guess that I did. And the first guess that I did ended up with a 5-digit answer, which I knew couldn't possibly be the right answer. So that tells me I've got to keep a small number. So if I'm going to multiply 4 times a as my last step, that can't be a 2-digit number, because if it is, that is going to make a 5-digit product or a 5-digit answer. So if I think about this, so a could be 0, but then I'd have a 0, which that'd be 3 digits, so that doesn't work. Or I could let a be equal to 1, because 4 times 1 is 4, and that's 2 digits. Or I could let a be equal to 2, because 4 times 2 is equal to 8. Just to try to illustrate the point here, if I let a be 3, 4 times 3 is 12, and that's too big. That's going to push me over into that 5th digit. So that gets crossed out. So I've made an inference here. I've inferred that a either has to be 1 or a has to be 2. One of the other things here. So I'm going to write those two possibilities down. I'm going to say a is 1. So then my problem is going to look like a 1, B, C, D times 4 is D, C, B, 1. All right, or the other way I could do is let A be 2, so that's going to be 2, B, C, D times 4 would turn into D, C, B, 2. All right, if I look at these, it tells me something else as long as I really think about this. So the first thing that I'm going to do when I perform this multiplication is I'm going to do 4 times D. Right? If I do 4 times D, I'm going to end up with the second digit of that product being a 2 or a 1. All right, so let's say D is 1. 4 times 1 is 4. Nope, not going to work. 2, now I can't even use 2 because I already used 2 for A as a possibility here. I could do 3, so 4 times 3 would be 12. That would give me a 2 here. 4 times 4 would be 16. D's not 4. 5, 6, 7, 8, 9. So you go through all of those and you realize that the only one that's going to work here is if D was 3. All right, but let's see if we could find something here. If I do 4 times 1 is 4, not a 1. 4 times 2 is 8, not going to work. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. 4 times 9 is 36. If you notice, whenever I multiply by 4, I end up with an even number. I can't get a 1 here. So this gets eliminated. this one is not going to work. So I can eliminate this. I can then decide, hey, A has to be 2, and I can also make the decision here that D would have to be 3. So I've already gotten down to the point here that D is 3, A is 2, and probably with even some more inferences, you could get to the answer pretty quickly. So I'm going to stop here and just kind of do a quick recap that our first approach of random guess and test, while you could do it, it's going to take forever. Systematic guess and test, we could keep track of everything we tried and just make sure that we try every single combination. But the third approach, which is inferential guess and test, is the one that really works well. So if you get a handle on what the problem's doing, what's happening in the problem, and then you use some reasoning, such as reasoning that, hey, A's got to be either 1 or 2, it's going to help you get to the answer a lot faster. So that's it for this screencast. Thanks.